So 7.4, I'm going to add and subtract rational expressions and do some complex fractions. Adding and subtracting rational expressions follows the same rules as adding and subtracting a regular fraction. Before you can add or subtract a fraction, you have to have a common denominator. So example A, if I have 3/5 and I add 7 more fifths, that leaves me with 10/5 or simplified. Same with variables. So in B, we can see we already have a common denominator. So we can just subtract across the top. And then simplify. Now, just like with adding and subtracting fractions, if you do not have a common denominator, we need to find a common denominator. The way you find a common denominator when we're dealing with variables is you need to focus on the factors. So while this first example, I'm sure you could find a common denominator or the least common denominator without worrying about the factors. It's good practice to look at the factors because we have to when we're dealing with more variables. So for example, 4x squared, I can write that as 2 times 2 times x times x. And 8x squared, that's 2 times 2 times 2 times x. Now, your least common factor needs to have every type of factor, so every different factor. In this case, all we have is 2's and x's. And you need the most from each. So this has the most x's, which is 2. This one has the most 2's, which is 3. So my least common denominator is going to be 2 times 2 times 2, which is 8, and x times x, or x squared. So if we're looking at our next one, 5 is a factor, x is a factor, 5 is a factor, and x minus 3 is a factor, the entire thing. When you put parentheses around a term like this, the entire thing is a factor. So I can say I need a 5, I need an x, and I need an x minus 3 for my lowest common denominator. So a 5, an x, and an x minus 3. All of those are distinct factors, and there's at most one of them in each. Now, something we're going to need to do a lot when we're worrying about factors is factoring. So for example, x squared minus 9, that's a perfect square. Or I should say that's the difference of squares. I can write that as x plus 3 times x minus 3. So my factors are x plus 3 is a factor. I already have x plus 3, and x minus 3 is a different factor. So my lowest common denominator, I need x plus 3 and x minus 3. So it's going to be important to know what your factors are and how many you have. Okay, let's solve some examples. So for A, one denominator is x plus 5, one is x minus 2. Whenever you have terms that are added or subtracted, that combines them into a single factor. So x plus 5 is a factor, x minus 2 is a factor. So to make a common denominator, we're going to need x plus 5 and x minus 2. So multiply this side by x plus 5 in the bottom, and multiply this one by x minus 2. Now, whenever we're adding, subtracting, simplifying expressions, you're not allowed to change the value. So in this case, we're going to multiply by 1, because multiplying by 1 doesn't change the value. So if you have x plus 5 in the bottom, you need x plus 5 in the top. Same here, x minus 2 in the bottom, x minus 2 in the top. So we have our common denominator, so we can subtract across the top. Let me put our common denominator first. This is going to be x minus 2, x plus 5. General tip, don't distribute your denominator unless you have to. Most of the time you could just leave it factored. So x minus 2 times 1, which is x minus 2, minus 3 times x plus 5. Now from here, we're going to distribute and simplify the numerator. Let's put it over our denominator again. That's going to be x minus 2, then distribute, minus 3x, minus 15, combine like terms. Minus 2x minus 17 over x minus 2, x plus 5. Now, in some cases, we're going to have a problem that looks like B. Before we can find what our common denominator is, we need to know what the factors are. So we have to make sure everything in the denominator is factored. So do a quick diamond problem for this. Let's say 5 minus 6, 5 times 1, negative 5 times negative 1 is 5, negative 5 plus negative 1 is minus 6. Since our leading coefficient is 1, we can skip right to factored form. So this will factor into x minus 5, x minus 1. And one thing you notice I do, it's a good habit to get into, when you see something in a denominator like this with things added or subtracted, put them in parentheses. Okay, now we can identify our factors. We have an x minus 5, an x minus 1, and we also have an x minus 1 here. So common denominator is going to be x minus 5x minus 1. So I'm going to multiply here times x minus 5, top and bottom. So you can see we have a common denominator now. So now I can add across the top x plus 2. Now I'm going to do two steps at once. I'm going to distribute this and then add it here. So I'm going to say plus 6x minus 30. Combine like terms. Now, after you have added, combined like terms, and simplified the numerator, you want to check to see if it is factorable. In this case, 7 and 28 are both divisible by 7. Now, the reason we do this is sometimes after you factor the numerator, you can simplify further. Like there'll be something that can cancel or reduce. In this case, all the factors are different, so that's it. Now, as I've been doing this, I've kind of been following a list of steps I have in my head. So let me write that out. So when we're dealing with adding and subtracting rational expressions, the first thing you want to do is to make sure you have factored just the denominators. Right? Because we need to find a common denominator. We need to know what the factors of the denominator are. So there's no need to factor a numerator, even if it looks like it can. Just don't worry about it. So after we know what our factors are, we're going to find our common denominator. Once we have our common denominator, step 3, we'll add or subtract. And also, after you've added or subtracted, you also need to simplify. So combine like terms, etc. So after you've added, subtracted, distributed, combined like terms, simplified the numerator as much as possible, you want to check to see if you can factor the numerator. Because sometimes after you have factored the numerator, there will be a step 5 where you can reduce or cancel a factor. Now, steps 4 and 5 are things we always want to check for, but they don't always happen. Sometimes the numerator is not factorable. Sometimes there's nothing to reduce or cancel. All right, so let's do example C, and we should see all the steps for this example. So 1, we want to make sure our denominators are factored. So x plus 2 is fine, nothing we can do there. We can definitely factor this, so I'll do a diamond problem. Minus 8 on the top, minus 2 on the bottom. 4 times 2, negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So I'm going to write out my denominator in its factored form. So again, our leading coefficient's 1, so I can write it as x minus 4 times x plus 2. So now we can see our factors. And again, at this stage, there's no need to factor the numerator, just leave it. So my factors are x minus 4 and x plus 2 and another x plus 2. So to make a common denominator, this has both my factors. This is just missing an x minus 4. And again, we always have to make sure we don't change the value, so we have to multiply by 1. So top and bottom the same. So that was step 2. We found our common denominator. Step 3, now we can add across or subtract across the top. So my common denominator is x minus 4, x plus 2. So in the top here, I have x squared minus 2x minus 38. Now here, I'm going to do both steps. We need to distribute, but not just the 5. We need to distribute minus 5, because we're taking away the entire numerator, not just a piece of it. So minus 5x minus 5 times minus 4 plus 20. So now we want to simplify the top, combine like terms. Let me write my common denominator again. So x minus 4, x plus 2, x squared, and then minus 7x. And then minus 38 plus 20, minus 18. Step 4, we want to check to see if we can factor the numerator now that it's simplified. So let's see, do a diamond problem. Minus 18 and minus 7. Looks like 9 times 2. Minus 9 times 2 is minus 18. Minus 9 plus 2, minus 7. That works. So I'll write it factored. So let's say x minus 9 times x plus 2, because again, we have a leading coefficient of 1, so we can go right to the factored form. My denominator was x minus 4, x plus 2. And we can see, in this case, we end up with a common factor in the top and bottom. We can divide. X plus 2 divided by x plus 2 is 1. So we're left with x minus 9 over x minus 4. Okay, so next we're going to simplify what's called complex fractions, or just fractions within fractions. There's really 2 concepts we need for this. One is what we just did, so adding or subtracting rational expressions. The other is what happens when you do a fraction divided by a fraction. So this is probably something you've seen in Algebra 1. So if we have, say, a over b divided by m over n, you've probably heard stay, change, flip. Now this is something they tell you early in your math life, because most of the time when you're at the age they teach you this, it's easy enough to follow this rule. But the algebra you need to get there is a little bit more difficult, but I think you're at the point now you can understand it. I'm going to show it to you at least once because I think it's good to see. But after that, you can just do this. So I can write a over b divided by m over n in a different way. I can say a over b divided by m over n. Now I want to simplify this. And as usual, if you want to simplify something, an expression, you can't change the value, so we can only multiply by 1. My goal is going to be to make the denominator 1. So I want the m to cancel and the n to cancel. If I multiply it by n over m, they should cancel out. But again, I'm only allowed to multiply by 1, so I have to multiply the top by n over m. So that's going to be a over b times n over m all over m over n times n over m. N divided by n is 1, m divided by m is 1. All of that is over 1. So that becomes a over b times n over m. And again, now that you've seen the algebra, you don't have to do this every time. We can definitely skip from here to here because it's always going to work. All right, let's jump into an example. So we want to eventually do the stay, change, flip, but before we can do that, we need to simplify the numerator and denominator. We need to add them or subtract them. Now 4 I can write as 4 over 1. 3 I can write as 3 over 1. And we want to add these as fractions. So our factors in our denominator are x and 1, x and 1. So our common denominator is going to be x. So multiply here by x over x, and I'm going to multiply here by x over x. So I have a common denominator on the top, so I'm going to subtract across the top. So this will be 2 minus 4 times x over my common denominator of x. And then here, my common denominator is x again. And my top is going to be 2 plus 3x. So now I can do stay, change, flip. So the top stays 2 minus 4x over x. Change division to multiplication. Flip the second. X over 2 plus 3x. We can cancel the x's, and we're left with 2 minus 4x over 2 plus 3x. Now we can factor the top a little bit, but it's not going to let us cancel anything. All right, let's do a couple more. So for b, the top is a fraction. That's good. The bottom, I need to combine before I can do state change flip. My factors are x plus 1 and x. So my common denominator is going to be x times x plus 1. So this side needs an x plus 1. And this side needs an x. So now I have a common denominator. Can add across the top. So 2x plus, and then I'll distribute, plus 3x, and then 3 times 1 is 3. Over my common denominator, x times x plus 1. Now that the top and bottom are fractions, we can do state change flip. So top stays 12 over x minus 3. Division changes to multiplication, and we flip here. So x times x plus 1 over, and I'm going to go ahead and combine like terms. 2x plus 3x is 5x plus 3. Now here, does not appear we have any factors that we can reduce or cancel. All of these are distinct factors, so we just multiply across. 12x times x plus 1 over x minus 3 times 5x plus 3. All right, one more. So here, step 1, we want to make sure our denominators are factors. X plus 2 is good, x minus 2 is good, x minus 2 is good. X squared minus 4, that's difference of squares. So I can write that as x plus 2 times x minus 2. So on the top, my factors are x plus 2, x minus 2. This denominator has both. This needs an x plus 2. Now my denominators are the same. Factors on the bottom, x plus 2, x minus 2. So this one needs an x plus 2, and this one needs an x minus 2. Now, one thing you want to make sure you do, or one thing you need to keep in mind as you're doing this, we're treating the numerator and denominator like they are separate problems. They're separate adding and subtracting rational expressions. So like we could ignore the denominator and find a common denominator and subtract the top. Then you could ignore the numerator, find a common denominator, and add the bottom. So I'm just doing both at the same time. So now we have a common denominator. So my common denominator in the top is x plus 2, x minus 2. So I can subtract across the top. And I'm going to go ahead and distribute. So 3 x plus 6 minus 6. And then in the bottom, my common denominator is, again, x plus 2, x minus 2. So I'm going to add across the top, and I'll go ahead and distribute also. So 3x, 3 times negative 2 is minus 6, plus 1x plus 2. Right. We can do state change flip. I'm also going to combine like terms. So this stays, and we can do plus 6 minus 6 is 0. So we're left with 3x over x plus 2, x minus 2. Division changes to multiplication. I'm going to flip this over. So the top is now x plus 2, x minus 2. I'm going to combine like terms. So we'll have 4x, negative 6 plus 2, minus 4. And we can see we're going to have some factors that cancel out. So x plus 2 divided by x plus 2, x minus 2 divided by x minus 2. So we're left with 3x over 4x minus 4. And we could factor the denominator, but it's going to be another case where it doesn't really change anything. So we factor out a 4, we're left with x minus 1. Still nothing we can reduce or cancel, but it's always good to check.